Okay. Hello, everyone. Good evening, sir and ma'am, all the panelists who's watching this presentation. Thank you for joining me today as I present my project on PHP 8.1.0 Dev exploit as my project presentation for Garuda ACE program application. About this project, actually, this is not the hardest project I have ever done, yet it was the most fundamental project I ever done, because after this, I was able to initiate more projects, especially related in cybersecurity. This was one of my first projects in cybersecurity, specifically focused on learning about and recreating an existing vulnerability. Although this vulnerability was documented in a CVE release back in 2021, to me, it presented an excellent learning opportunity, especially as a beginner in exploit development, because through this project, I wanted to dive into how known vulnerabilities can be tested and used for educational purpose. I researched about the CV back in 2023 and developed the exploitation of this vulnerability at the end of the same year. So today I'll be walking you through the project goals, some technical challenges I encountered, and how I design it and implement the solution, as well as the pros and cons I discovered along the way. So let's get begin. Okay. Okay. On the first I want to explain is about my project goals here. The main objective of this project was to understand the process of building an exploit script for a documented web vulnerability, specifically one affecting PHP version 8.1.0 Dev, because this vulnerability included a backdoor that allowed for RCE or remote code execution, essentially giving attackers a way to run commands on a server without authorization. My goal here wasn't to use this for malicious purpose, but to gain a hands-on understanding of how exploit development works from start to finish. So this involved a few key aspects. I have categorized it into 3 points. The first one is about learning the exploit mechanism, because by recreating the exploit, I wanted to understand how the vulnerability worked on a technical level, specifically about how PHP server headers could be manipulated to execute arbitrary commands. The second one is about scripting for automation. Here, I also wanted to create a script that automates the process, enabling me to see the exploit in action without manually crafting HTTP requests each time. This was a valuable skill to me, as scripting is also essential for reproducible and efficient testing, especially in the cybersecurity aspect. And the next one is ethical and educational use, because here I strictly tested the exploit in a controlled environment. This setup allowed me to learn safely without putting real-world systems at risk. So because of that, emphasizing the importance of ethics in cybersecurity. Therefore, this project has helped me gain hands-on experience in a safe yet educational context, and also became the foundation of my knowledge and skill to craft my own script in terms of penetration testing, especially in this case, web security. Okay, so we're moving to the next slide. Here, about technical challenges I have encountered throughout the project. I encountered a few technical challenges that taught me a lot related to this project. The primary challenges, I categorized it into 3 points again. The first one is about understanding the backdoor mechanism, because since the vulnerability had been documented, there were resources available about the CV, but I still had to interpret these resources to understand the technical details of the backdoor. So this CV information that spread across the internet provided a starting point to me, because but because learning to structure the exact HTTP request format, especially the user agent header, was a crucial part of making the exploit functional. So yeah, I have to gather information and learn everything about this, everything related about this project first. So the second one I encountered was crafting HTTP requests correctly, because when creating requests that PHP would interpret correctly, it involved working with Python's request library, the library request from Python. This, to me, required practice and understanding of how to format headers, data, and others HTTP elements to ensure the target server could interpret them as expected. Any small mistake in the header or data could break the exploit. So getting these details right took a lot of trial and error to me. And the third problem I encountered is about the output parsing, because finally handling the command output reliably presented another challenge. I wanted the script to display the results of each command clearly without any extra or malformed text. This means parsing the output precisely, especially by marking the end of the command with um, I'll be talking about this. So there's this called end of command, so that the only command's result would be shown. These challenges were both technical and practical to me, and it does making this project a very insightful learning experience to me. Okay, so next we'll be talking about the design and solution. Before we get into the solution, I had like to briefly overview the vulnerability. So the vulnerability lies in the PHP version. It's 8.1.0-Dev, specifically related to how it handles the HTTP request headers, particularly this one header called user agent. So this vulnerability was documented as a part of a CVE release, and it exists because uh, due due to a backdoor introduced in the development version of PHP. There's a story behind it too. If there's time, I might talk about it. This vulnerability allows an attacker to inject arbitrary PHP code into the server by manipulating these specific HTTP headers. The key issue here is the improper handling of HTTP headers. Specifically, as I told before, a header called user agent, but this time is modified into user agent with an extra T. So it's user agent T. So this header was introduced unintentionally during the development of PHP 8.1.0-Dev. There's one release back in 2021. This header allows PHP to execute system commands on the server, which leads to remote code execution, or RCE, which is a critical vulnerability that can potentially allow an attacker to execute this arbitrary code on a web server. So when an attacker sends a specifically crafted request with the user agent with extra T header, that user agent header, which containing PHP code, which the keyword that will trigger it, it is 0 It's on the left side of the screen. So the 0 is actually the trigger where the server interprets the code as part of the request and execute it. This means that the attacker can run system commands or access sensitive data on the server, which is exactly what this vulnerability allows. So if we execute the header as displayed on the presentation, the PHP server will execute the system function and run any shell commands passed via the CMD parameter. And also, this is how an attacker can gain control over the server by passing malicious commands through this CMD parameter in the request body. And this vulnerability actually was patched after being reported, so it's no longer present in modern PHP release. However, to me, it provided a great opportunity to explore, exploit development, and practice reverse engineering security flaws in a controlled and ethical environment. So I used this in a sandbox. I made a couple of sandbox, and also I used it in several CTF challenges. So now let's have a look on the right side is about how I designed the solution to exploit this vulnerability. Is implemented in a Python script which automates the exploitation process. The script here essentially interacts with the vulnerable PHP server. It sends the crafted request and retrieves the output of executed commands, uh, which will trigger the RCE backdoor. So I categorize it into three main steps. The first one is about the version checking. There is a function there, you can see. It's about the version checking. The first thing the exploit does is check the PHP version of the target server to confirm it is running the vulnerable version. I achieved this by sending a simple GET request to the target URL and inspecting the response headers. Specifically, that one header called X powered by, which is usually consists about the version of the backend system running. If the server here is running PHP 8.1.0-Dev, it will return a value like, for example, PHP slash 8.1.0 min dev. There you can see on the code. This confirms that the server is vulnerable to the exploit. This step is crucial to me because I don't want to waste time or resources attacking a non-vulnerable server. If the server doesn't match the expected PHP version, the script will notify the user and abort the process, ensuring that we only target the vulnerable servers. And the second step I made here is the header injection for the RCE. So once the server is confirmed to be vulnerable, the script proceeds with exploiting the backdoor by injecting a specially crafted post request, that one zero var stuff. And this request contains the malicious user agent header, which I said before, with PHP code that is designed to execute shell commands, which is the zero var as the keyword to trigger. And the exploit leverage the system function in PHP, which allow execution of command on the server's operating system. But in the script, I send a post request that includes the CMD parameter, which the server will process. And the next step, the third step, is about the output parsing and displaying the exploit if it's working. So after the server executes the command, the exploit collects the output and display it in human readable format. To capture the output correctly, here I use a regular expression to parse the response tag and extract the relevant data, which I mentioned before, the end of command marker, which was sent on the pause request on the second step, ensure that the output is clean and without extraneous information. So I think to summarize the exploitation that I made, this exploit works by first confirming that the target server is running the vulnerable version of PHP. Then it sends a specifically crafted post request which containing a malicious header to execute arbitrary system commands via PHP's function system. And finally, the exploit parses the command output and displays it for the user. Okay, so that's for the solution I made, which is in form of exploitation for vulnerability. Now we are moving to the next slide. Here I have pros and cons I have encountered. So the strengths and weakness of this approach. First one is about pros. It's hands-on educational value to me. So this project was actually a great way to gain hands experience, as I mentioned before, with real-world exploits, but in a controlled and educational manner, which allowed me to apply theoretical knowledge about web vulnerabilities and see how such vulnerabilities can be exploited. And the second one of the pros that I encountered is that I learned automation through Python. Um, what to remember that this project was done last year. So using Python's request library for um, automation, it the process became faster and more efficient, which providing reproducible steps for testing against a vulnerable server. And the cons I encountered, the first one is it is there is a limitation on the version specification. So as we know, the exploit only works on PHP 8.1.0 Dev, which significantly limits its use. Also, since this version has been patched and the vulnerability is no longer widely exploitable, so it's reducing its real-world applicability today. And the second of the cons that I encountered is about the potential for detection, because the exploits approach, especially with the user agent with XRT header injection, it could easily be flagged by security software, particularly on systems with modern intrusion detection capabilities. So that's for the pros and cons I encountered. Let's getting move. Okay, about other challenge. There were a few additional challenge that worth mentioning. The first one is about learning curve with Python. So in this project, I have to understand Python's library, that one library called requests, and how to manipulate HTTP requests. Uh, and this were a big part of this project because it took time to get comfortable with sending HTTP requests in Python, especially with header manipulation. And the second one challenges I encountered that is also worth mentioning is about command parsing complexity. It's and ensuring that the output was parsed correctly, so it displayed only the necessary information, was more complex than I initially anticipated, because by marking the end of each command with that one string end of command, I was able to avoid errors or misinterpretation. But this required thoughtful testing and debugging, which must be encountered through trial and errors. And this part also emphasizes about how small details can make a big difference in exploit usability and clarity. Okay, so that's the other challenge I encountered. Now we're moving. Oh, it's the end. So, okay, in closing, to summarize, this project to me was a fantastic learning experience because it reinforced my understanding of exploit development and web security. One of the most important takeaways here was the ethical responsibility that comes with knowing how to exploit vulnerabilities. Um, yeah, maybe while this project was conducted in a safe environment, it is a safe reminder of why we need ethical standards in cybersecurity. Because learning how exploits work is one thing, but using that knowledge responsibly is essential. Okay, I think that's all for my presentation about PHP 8.1.0 Dev exploit. Thank you so much, sir, ma'am, all the panelists for watching this presentation. And it is such an honor to present this in front of everyone. Good evening and thank you.